All right then, econ friends, welcome back for another video. In this video, we're going to do just a little bit of an extension in our economic growth theory, and we're going to talk briefly about the Solow growth model and take a look at a production function and try to put some of the stuff that we've done in the last couple of videos together, kind of synthesize it and see if we can make some sense out of it through the production function, okay? One of the big people behind this production function way of thinking is a great economist named Robert Solow. He's a professor of economics at MIT. So a lot of this, the work that I'm talking about here goes back to his theories, which have become very powerful and very well regarded, okay? We also have a group of proponents that are known as the new growth theory economists, who have taken the Solow model and then expanded that even further, okay? So let's start off. Again, several economists, notably Robert Solow from MIT, as well as the proponents of what we call the new growth theory, they have developed and extended a production function to synthesize and illustrate the factors that we discussed before in prior videos, okay? Now, we'll deal with production functions in a lot more detail in our micro discussion on the theory of the firm. But for now, we can take the whole aggregate total economy and take a look at it. I don't want you to get too uptight or afraid of this jargon. Generally, okay, in general, all a production function does is it simply describes the relationship between inputs and outputs in any production process, okay? What Solow has done is he has taken the production function and he has put it into a formula. You see that right here, okay? Let's go through it really quickly. The Solow, this is, of course, a simplified model, but this simplified model of the Solow production function says that Y, which is GDP, that Y is a function of K, H, and N, okay? That Y is a function of K, H, and N, where Y equals real GDP per capita, K represents physical capital, H represents human capital, and N represents natural resources. All this means, don't worry about the symbols, don't get hung up on the math. All this says simply is that real GDP per worker, so for any country, real GDP per worker is simply a function of the physical capital, human capital, and natural resources in that economic system, in that economy, in that nation. Notice, my friends, there's nothing new here. All we've done is taken the previous stuff, the previous factors, and kind of synthesize them into a nice, simple model. This is the Solow growth model. Now, there's a lot more subtleties to it, which we can go over if you want, but at its simplistic, basic part, real GDP per capita is equal to a function of physical capital, human capital, and the natural resources that an economy has, okay? Notice that we can take this and put it into the production function picture, which you see right here, that we had before. And if you look at that, what you will notice is that the slope of the production function reflects the law of diminishing returns, which in turn suggests that at some point, there's going to be no incentive to build or invest in new capital, okay? We did this before. We'll touch on it one more time. You see again that in this production function, which is characterized by the Y is a function of K, H, and N formula, which you see right here. You see that we have real GDP per worker, physical capital per worker. Physical capital is the input. Real GDP per worker is the output. The production function that you see here simply shows the relationship between inputs and outputs. Don't overcomplicate it. It shows a relationship. It's a graph, it's a picture that shows, that visually represents the relationship between inputs and outputs. Notice again that in the early, so here's our curve, here's our production function. Notice here that in the early phases, it's very steep sloped. But as we go farther and farther along, as we add more and more physical capital, we see that real GDP per worker starts to flatten out. We see that the slope starts to flatten out. That slope, my friends, simply represents the law of diminishing returns, okay? To synthesize this with earlier stuff, what our Solow model implies then is that due to diminishing returns on capital, the economy will eventually reach a condition that we call steady state, okay? Again, the Solow model shows in the production function that there's diminishing returns. Seen a different way, it shows that over time, adding more and more capital will give us less and less gain, right? We're going to get less bang for the buck. This then implies that over time, economies will have less incentive to build new capital, to invest in new capital. All this is put together in what Solow calls the steady state. And the steady state is a condition where net investment equals, sorry, let's make this cleaner, where net investment equals zero. The steady state is where net investment equals zero. In other words, where the spending on new capital just offsets the depreciation of existing capital. And therefore, there is no new net investment. You might notice that this reinforces what we said earlier, that capital accumulation by itself cannot be sufficient to sustain long-term economic growth, because we predict through the Solow model that we will not have ongoing infinite increases in the capital stock. The Solow model implies that we will reach steady state, that economies will at some point have zero net investment, that they will simply be forced to spend money to offset depreciation. That implies that the capital stock will stop growing. And that concludes with the assumption that capital accumulation by itself will not be sufficient to give us long-run sustained growth. Critically, the Solow model offers us a way out of this conundrum, because the model holds that technology and innovation, that ideas, that progress can shift or boost the production function. And that's the beauty of technology. It can offset diminishing returns to capital. And this is one of Solow's insights. We add to that the new growth theory contention that good, inclusive institutions, that those institutions that we mentioned earlier, that they can increase the productivity of existing resources. So institutions also shift or boost the production function. We can account for this technology and innovation and institutional factor by taking that original simple Solow growth model, the one that we did at the beginning of this video, and rewriting it just a little bit. And take a look at this rewritten one. Here, we say that y is equal to a times the function of k, h, n plus institutions. This is a modified and enhanced production function formula. Y equals GDP, which equals A, multiplied by the function of K, H, N, and institutions. Notice here that what we're adding in is A, which represents technological change and innovation, as well as institutions. So we took that existing production function, and now we're going to see, in terms of production function graphics, what technology and what institutions can do to it. And basically, here's what it does. Same idea, real GDP per worker here, capital per worker here, and regrettably, this flattening out production function, which shows diminishing returns. Here, my friends, is what the A, innovation and technology, and what the institutions, good, inclusive institutions, do. They take this original production function in red and they boost it. They shift it. They push it up. And this means that even if we keep physical capital per worker constraints in mind, real GDP per worker will grow. And that, by definition, my friends, is economic growth. So we conclude with the idea that given the Solow production function, the Solow growth model, as well as the work of the new growth theory economists, innovation and ideas and technology combined with good institutions can help us offset diminishing returns, can help us offset limited natural resources by taking our existing production function, the original one here in red, and boosting it, shifting it up, giving us more bang for the buck over time, giving us economic growth. Thanks, my friends, and I'll see you next time for our final video on growth theory. Thank you.